Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, we are going to have like some practice on proportions and similar figures. So when we say similar figures, we mean like two shapes that are the same, like two triangles, two rectangles, two trapezoids, two circles, and one of them is either like we can think of it as one is a reduced version or an enlarged version. Okay, so meaning that if I look at these two triangles, you see that these two angles are congruent, meaning they are, when you put them on each other, when you put these two sides on each other, they will coincide with these two sides, meaning the angle between them is exactly the same measure. Same thing with angle M and P, same as O and R. But the ratio of the sides is the same. If this is half of that, then this is half of that, and this is half of that, and so on and so forth. Okay, so again, the first one, the first problem here, the first two, I'm going to skip them. They tell you which angles and which side are corresponding. Like, you know, these two are corresponding, these two are, and so on and so forth. So that's trivial, really. So let's pick some of the rest of the problem. So on this page, we have similar shapes. So maybe we take the odd numbers. You can see that you have, in fact, I have another video that talks about fractions and how we equate fractions. In this case, you can say that the ratio of 9 to 12 is the same as 4 to m. Or I could have said 12 to 9 is the same as 8 over 4. Or I could say 4 to 9 is the same as m to 12. All of these are okay. Or 9 to 4 is the same as 12 over m. Whichever way you do, it's fine. But then once you have this equation, we use the cross or the scissors. We are going to multiply these two, and we say, or some people call it the butterfly, because when you draw it, it looks like a butterfly. 9 times m, or 9m, equals 4 times 12, equals 48. So when you divide by 9 both sides, the 9 cancels, and you get m equals 48 over 9. Both of them are can be simplified by 3. So m here equals 16 thirds, or 5 1/3. And of course, units. So we don't have units to do. So if we can easily find m using this method. Okay. Okay, when we move to number 5, I can do the same thing, but maybe I'll do it slightly different. I'm going to say 5.2 over 4.8 equals x over 19.2. So the similar corresponding sides, if I put 5.2 as a numerator, for the big triangle, I put the corresponding side as the numerator. I put this as a denominator, so I put that as a denominator. Or, as I said, I can divide 5.2 over x. So the two corresponding, I started with the small, ended with the big. So I start with the small, and I say it's 4.8 divided by 19.2. Both of them are correct. When you get fractions, it's better to start by multiplying top and bottom by 10, because when you do that, you get 52 over 48 instead of saying 5.2, instead of using decimals. So I could have written this as 52 over 48, and I see that these two numbers are divisible by 4, right? We know that we have 4 suits in playing cards, and each one is 13. So we have 52 cards. We know that it's 52 is 13 times 4, right? And 48 is 4 less, so it's 12 times 4. So I could have divided by 4 and say 13 over 12. So I say 13 over 12 equals x over 19.2. And again, I do the butterfly or the crisscross, and I say 12x equals 13 times 19, times, because I don't want you to think it's another x. And then I'm going to divide by 12 each side. When I divide this by 12, I get 1.6. Okay, use the calculator if you are not sure. 19.2 over 12 is 1.6. And 1.6 times 13 is 20.8. So x equals 20.8. And it has to make sense to you. This is bigger than that. So x has to be greater than 19.2. Of course, we don't know exactly how large, but if I end up, for example, with 14.7, I say it cannot be smaller than this if 5.2 is greater than 4.8. So if I reverse and get a crazy number that doesn't make sense, I know I did it wrong. Also, this is more than twice the 4, roughly twice, right? 4 times 2 is 8, so roughly twice. So this would be roughly half, and half of 12 is 6. If I get 5 point something, it makes sense because that's a little less than half, so that's a little less than half. Again, if I get 25 point something or I get 30, I know, oh my God, no, something is wrong. So I can catch these types of errors. Always think before you submit your answer. We are taking the odd numbers, so let's see what they ask here. The scale of a map is 0.25 centimeter to every 15 kilometers. So if you have a 15 kilometer, of course, I cannot draw 15 kilometer, or else why would I use a map? A map is always a reduced scale of real life. So if 0.25 centimeter are equivalent in reality or in nature to 15 kilometer, how much is 2 centimeter? Well, I do the same thing. I say 0.25 centimeter over 15 kilometer equals 2 centimeter over x kilometer, and solve for x. So I do the cross. So I get 0.25x equals 2 times 15, or 30. And then notice that some people prefer to do that. 0.25 is a quarter. So it might be easier to say 1/4 of x equals 30, and then I multiply both sides by 4. It's the same thing as dividing both sides by 0.25, but most likely you would use a calculator for that. Here you don't really need a calculator. You can say just x equals 120 kilometer. You have to enter the unit. Don't leave it as a number. And you say, but you did that in the last problems. Yes, because I wasn't given dimensions. They didn't tell me these are like 4 inches and 9 inches. Then I would say this is 12 inches. Then m would be 5.5 inch. But if they don't give you units, you leave it as a number. But if they give you units, you have to use that. Again, I could have done here 30 divided by 0.25, and sure enough, I get 120. But if you know a fraction is a half or a quarter, it might be easier to multiply rather than divide and not need a calculator. 5.25, okay, it's the same thing. 5.25 over 15 equals, I'm sorry, I said 0.25 over 15 equals 5.25 over x. Again, there is no reason to have a decimal place. I can multiply both numerators by 100, right? So that would be 25, and that would be 525. And I can say 25x equals 15 times 525. In fact, this over that is 21. You should get 315 as x. But I'm going to divide by 25 both sides and use my calculator and say 15 times 525 over 25 equals 315 kilometers. Or I could have done it from the get-go, right? I could have left this as point and say 15 times 5.25 divided by 0.25. I still will get 315. Number 11. And we have, maybe this is an open-ended, and this is the reason. So maybe we'll do 11 and 12. An architect created a scale model of what a college campus would look like once construction is finished. The scale of the model, again, model is like the map. You do a reduced model, right? I'm not going to build the whole building and say, oh, this is the model. Then, okay, so 2 inch is equivalent to 25 feet. The tallest building in the model is 10 inches. Again, model is equivalent to, 2 inch, 2.0. I'm going to write it over 25 equals model over actual. 2 over 25. This is 2 inches. This is 25 feet. The tallest building is 10 inches. So I put the inches with the inches over X feet. So how tall is the building? I see that if I do the same thing as we did before, the butterfly method, 2x equals 25 times 10 equals 250. So I'm going to divide by 2 both sides, and I get x equals 125 feet. Number 12. Very similar. This is just a review and to let you be more confident and do these problems quite easily. A model of a golf course says that hole number 9 is 175 yards long. If the scale of the model is 2 inches, again, 2 inches is equivalent to 20 yards. How many inches, so X now is how many inches in the scale in the model, is equivalent to 175 yards. And again, when I cross multiply, I get 20x equals, 20x equals 2 times 175. 2 times 175, well, in fact, I can divide by 2. So I divide by 20, I divide by 20. So I get x equals, the 2 and the 2 would make that 1, and this is 10, and 175 over 10 is 17.5 inches. Okay, so I divided 20 by 20. And again, I could have said x equals, if I divide by 20, I say x equals 2 times 170. Oops, I'm sorry, where is the natural log coming from? Okay, 2 times 175 over 20, and it's 17.5 inches. I think that was a quick one, a quick review on proportions. We'll take maybe another worksheet tomorrow on fractions, and then we will combine them and see if we can get something more interesting. And then we'll be done with this part of the course. We'll move to inequalities. Okay, and we'll under inequalities, or maybe I'll do absolute values first. We'll see. It doesn't matter, but both are easy concepts, but you have to learn them. You have to learn them very well because these are the building blocks. That's your foundation. And your foundation has to be strong so that when you build on it, you will have a solid building. It's not shaky. Okay. So don't hesitate to ask questions, to write comments, and challenge me if I did something wrong or something that doesn't make sense to you. Because the more deeper you understand these concepts, the better you will be in math in the future. I wish you all the best, and I hope to see you tomorrow. Have a nice day. Bye.